To determine the wire size for the service cable, we need to calculate the total load. The grocery store has a load of 90 amps. Apartment 1 has a load of 60 amps. Apartment 2 has a load of 60 amps. The total load is 90 amps plus 60 amps plus 60 amps, which equals 210 amps. For a 200 amp service, according to table 310.16 AON for 120/240 volt service, we would need number 2 AWG aluminum or copper. For the apartment feeder, we can use table 310.15 B6 since it applies to residential occupancies. For a 60 amp feeder, we would use number 6 AWG copper or number 4 AWG aluminum. For the grocery store feeder, we would use table 310.16 AON for commercial occupancies. For a 90 amp feeder, we would use number 2 AWG copper or number 1 AWG aluminum. It's important to verify local codes and consult with a licensed electrician for specific requirements and recommendations. This discussion focuses on determining appropriate wire sizes based on the calculated electrical load for a building containing a grocery store and apartments. The National Electrical Code, or NEC, provides tables to guide the selection of wire sizes based on amperage and voltage requirements. We'll look at how to apply these tables to specific scenarios, ensuring safe and compliant electrical installations. Firstly, it is crucial to accurately calculate the total electrical load. This involves summing up the individual loads of each unit or area, such as the grocery store and each apartment. In this case, the grocery store has a load of 90 amps, and each of the two apartments has a load of 60 amps. Adding these together, 90 amps plus 60 amps plus 60 amps, we get a total load of 210 amps. This total load figure is essential for determining the appropriate size of the service cable, which is the main cable bringing power into the building. Secondly, after determining the total load, we can consult the NEC tables to find the appropriate wire size. Table 310.16 is commonly used for general wire sizing, but specific tables like 310.15 B6 may apply to certain residential applications. For a 200 amp service, table 310.16 AON indicates that number 2 AWG aluminum or copper conductors would be suitable for 120/240 volt service. However, it's critical to remember that this is a general guideline, and local codes and regulations should always be consulted, as they may have more stringent requirements. Thirdly, when considering the feeder wires for individual units, such as the apartments, we can potentially use table 310.15 B6. This table is specifically designed for dwelling units and allows for a reduced wire size based on the assumption that not all appliances and devices will be operating at their maximum load simultaneously. For a 60 amp feeder to an apartment, this table would suggest number 6 AWG copper or number 4 AWG aluminum conductors. The use of this table is contingent on meeting all the conditions outlined in the NEC, so careful review is necessary. For the grocery store feeder, since it is a commercial occupancy, table 310.16 AON should be used. For a 90 amp feeder, this table would indicate that number 2 AWG copper or number 1 AWG aluminum conductors would be appropriate. It's important to note that the choice between copper and aluminum conductors depends on several factors, including cost, ampacity, and installation requirements. Aluminum conductors are generally less expensive than copper, but require larger sizes to carry the same amount of current. Aluminum also requires the use of approved connectors and antioxidant compounds to prevent corrosion. Ampacity refers to the current carrying capacity of a conductor. The NEC tables provide ampacity values for different wire sizes and insulation types. It's crucial to select a wire size with an ampacity that is equal to or greater than the calculated load. Overloading a conductor can lead to overheating, insulation damage, and potentially a fire. Insulation type also plays a significant role in determining ampacity. Different insulation types are rated for different temperatures. Higher temperature ratings allow for higher ampacities. The NEC specifies the allowable insulation types for various applications. In addition to wire size and ampacity, other factors to consider include voltage drop, conduit fill, and dirting. Voltage drop refers to the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause appliances and devices to operate inefficiently or not at all. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. Conduit fill refers to the amount of space occupied by conductors within a conduit. The NEC specifies the maximum allowable conduit fill to prevent overheating and damage to the conductors. Dirting refers to the reduction in ampacity of conductors when they are installed in close proximity to each other or in high-temperature environments. The NEC provides dirting factors to account for these conditions. Grounding is another essential aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. The NEC specifies the grounding requirements for various types of electrical systems and equipment. Bonding is closely related to grounding. Bonding connects all metal parts of an electrical system together to create a common ground potential. This helps to prevent voltage differences between different parts of the system, which can be a shock hazard. Overcurrent protection is critical for protecting electrical circuits and equipment from damage due to overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The NEC specifies the overcurrent protection requirements for various types of electrical circuits and equipment. Arc fault circuit interrupters, RFCIs, are a type of circuit breaker that is designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. The NEC requires RFCIs in many residential circuits. Ground fault circuit interrupters, or GFCIs, are a type of circuit breaker that is designed to protect against ground faults. Ground faults occur when current leaks from a circuit to ground. GFCIs are required in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Electrical boxes are enclosures that protect electrical connections and provide a safe place to terminate wires. The NEC specifies the requirements for electrical boxes, including their size, material, and installation. Wiring methods refer to the different ways of installing electrical conductors. Common wiring methods include conduit, cable, and raceway. The NEC specifies the requirements for each wiring method. Electrical panels are enclosures that house circuit breakers or fuses. The NEC specifies the requirements for electrical panels, including their size, location, and labeling. Lighting is an important aspect of electrical design. The NEC specifies the requirements for lighting in various types of buildings and spaces. Appliance circuits are circuits that supply power to appliances. The NEC specifies the requirements for appliance circuits, including their size and overcurrent protection. Electric motors are used in a wide variety of applications. The NEC specifies the requirements for electric motors, including their wiring, overcurrent protection, and grounding. Transformers are used to step up or step down voltage. The NEC specifies the requirements for transformers, including their wiring, overcurrent protection, and grounding. Emergency power systems provide power to critical loads during a power outage. The NEC specifies the requirements for emergency power systems, including their design, installation, and testing. Renewable energy systems, such as solar and wind power, are becoming increasingly popular. The NEC specifies the requirements for renewable energy systems, including their wiring, overcurrent protection, and grounding. It's important to stay up to date with the latest edition of the NEC and any local amendments. Electrical codes are constantly evolving to reflect new technologies and safety concerns. Consulting with a licensed electrician is always recommended when performing electrical work. Licensed electricians have the knowledge and experience to ensure that electrical installations are safe and compliant with all applicable codes. Permits may be required for electrical work. Check with your local building department to determine if a permit is needed before starting any electrical project. Inspections are typically required after electrical work is completed. Inspections ensure that the work was done properly and meets all applicable codes. Working with electricity can be dangerous. Always take precautions to protect yourself from electrical shock. Turn off the power before working on any electrical circuit. Use insulated tools. Wear safety glasses. If you are not comfortable working with electricity, hire a licensed electrician. Electrical safety is paramount. Following the NEC and working with qualified professionals are essential for protecting yourself and others from electrical hazards. Remember that this discussion provides general guidelines. Always consult the NEC and local codes for specific requirements. Working with electricity can be dangerous, so it's always best to err on the side of caution and seek professional assistance when needed. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or projects. The complexity of electrical systems necessitates a thorough understanding of the NEC and local codes. This discussion aims to provide a basic overview of some key concepts, but it's important to recognize that there is much more to learn. Continuous education and training are essential for staying current with the latest electrical codes and best practices. Electrical work is not a do-it-yourself project for the inexperienced. The risks are too great. Always prioritize safety and seek professional help when needed. Proper planning is essential for any electrical project. Before starting work, carefully assess the load requirements, wire sizes, overcurrent protection, and grounding. A well-planned electrical system will be safe, reliable, and efficient. Documentation is also important. Keep records of all electrical work, including wire sizes, circuit breaker ratings, and grounding connections. This documentation can be helpful for future maintenance and troubleshooting. Electrical maintenance is often overlooked but is crucial for ensuring the long-term safety and reliability of an electrical system. Regularly inspect electrical panels, wiring, and devices for any signs of damage or wear. Replace any worn or damaged components promptly. Consider using surge protection to protect sensitive electronic equipment from power surges. Surge protectors can help to prevent damage to computers, televisions, and other electronic devices. Lightning protection is another important consideration, especially in areas that are prone to lightning strikes. Lightning protection systems can help to protect buildings and equipment from damage caused by lightning. Energy efficiency is becoming increasingly important. Consider using energy-efficient lighting and appliances to reduce energy consumption and save money. Building automation systems can help to optimize energy usage and improve comfort. These systems can automatically control lighting, HVAC, and other building systems. Smart home technology is also becoming increasingly popular. Smart home devices can be controlled remotely using a smartphone or other device. These devices can provide convenience, security, and energy savings. The future of electrical systems is likely to involve even more automation, integration, and intelligence. As technology continues to evolve, electrical systems will become more complex and sophisticated. Staying current with the latest trends and technologies is essential for electrical professionals. The electrical industry is constantly changing, so it's important to be a lifelong learner. Take advantage of continuing education opportunities to expand your knowledge and skills. Networking with other electrical professionals can also be beneficial. Sharing knowledge and experiences can help you to stay up to date with the latest trends and best practices. The electrical industry offers a wide range of career opportunities. Whether you are interested in design, installation, maintenance, or sales, there is a career path for you. Consider pursuing a career in the electrical industry if you enjoy working with your hands, solving problems, and making a difference. The electrical industry is essential to modern society. Without electricity, our lives would be very different. Electrical professionals play a vital role in ensuring that we have a safe, reliable, and efficient electrical supply.